in the one-dimensional array, only one subscript. But when it comes to the two-dimensional array, it will be of pair of subscript. So one represents the row and another subscript represents the column. It will be a combination of rows as well as columns. This represents the rows and this side represents the column. So when we have a less number of elements than the size of an array, at the time by default the compiler will going to initialize that element value by 0. Hello everyone, a warm welcome to one and all. Welcome back to the session 2 of Unit 1's Chapter 2, and we are learning with B.C.A. second semester subject called Data Structures using C. I am Rohini T.S. Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So before getting into our today's session regarding this arrays chapter, let me have a quick recap of my previous session. So in the previous session of this chapter, we have learned regarding the definition of an array. So we got to know that an array is an ordered collection of elements of a same data type and it will going to share a common name. And also I have discussed regarding the types of arrays. How many types we have there in the types of arrays? That is of 3 types. First one is one-dimensional, second one is two-dimensional, and also we have a multi-dimensional. If it is more than two-dimensional, then it will be of multi-dimensional. And also I have started with a discussion of one-dimensional. So in the 1D or a one-dimensional, there we got to know the definition of one-dimensional. Along with that, we got to know how to declare that declaration of one-dimensional array. Along with that, I have discussed regarding the initialization of one-dimensional array. How the initialization, how we are giving the initial value at the time of its declaration. That is what I have discussed in my previous class. So in our today's session, we will go with the two-dimensional array. With the same thing, whatever we have done for the one-dimensional array, like its definition, declaration, and also initialization, that I will be doing with two-dimensional array. And also we'll see the definition of this multi-dimensional array. Then at last we will be learning regarding what are the basic operations that can be performed on the arrays. That is what I will be doing in my today's session. Let me get into the two-dimensional array now. So already we know about the one-dimensional, right? How many subscripts we had in the one-dimensional? That is only one. But when it comes to the two-dimensional, as the name indicates, it will going to have 2 subscripts. So here it can't be only row or column. It will be a collection or it will be a combination of both rows as well as the column, so that one subscript represents the row, another subscript represents the column. So here also it's an ordered collection of elements of a same data type and it will going to share a same or a common name. But here we are going to have 2 subscripts instead of 1. So that is what the definition here. It's an array in which each element is accessed using 2 subscripts. How many subscripts we have here? That is of 2. I already told you, when it is a 2 subscript, one represents the row, another represents the column. But it is a single subscript, or if it is of only one subscript, at the time it can be row or column. But here row and column, not R. It's and here. That is what. And the subscript always represents the position of an element in an array. It always specifies the position or a location of an element. And also of two-dimensional are represented as a rows and columns. So here it can't be rows or columns. It has to be row as well as column. So that rows and columns. If I wanted to fetch any of the element of an array, then I must know the row size or row number and in which column it is spacing. So that is you need to remember. In order to identify any element, first we must know the row number as well as column number. Then only we will be able to access that element. And also in the two-dimensional array, it's a collection of elements and each element will going to be identified with help of pair of subscript. So in the one-dimensional array, only one subscript. But when it comes to the two-dimensional array, it will be of pair of subscript. So one represents the row and another subscript represents the column. And also the elements are stored in contiguous memory location. Here also it will be stored in contiguous, one after another. This is also an ordered collection of elements. But instead of one subscript, we will be having two subscript. And also it will going to have rows and columns, so that the number of rows and columns in a matrix is called as the order of the matrix. And what it means? So if I have 2 cross 3, if I simply say 2 cross 3, what it represents? 2 represents m and 3 represents n. So m is nothing but row and n represents the column. So when we are mentioning 2 cross 3, it will be able to have 2 rows and 3 columns. How we are going to do that? It is of 3 column, right? So this is, it will going to include 3 columns and it has 2 rows. So that totally how many elements can be stored? 2 into 3, it will be 6. So that up to 6 elements can be stored when we are declaring or when we are having a size of a 2-dimensional array or order of the array as 2 cross 3. So that will going to be represented in the terms of m cross n. M represents row, n represent column. So here it's an example 2 cross 3, that is of 6 element can be stored. Fine. And how we are going to do the declaration, that I am going to discuss now. So as we did for the 1-dimensional array, here also I need to take a data type. Fine. Then we have to specify the name of an array. So in order to identify the array, the name of an array is important, so that you need to give a name. Then here instead of having 1 subscript, we have a 2 subscript. First subscript always represents the row size and second subscript always represents the column size. At last, don't forget to put this semicolon to terminate the declaration. Fine. So data type can be any of the data type. It can be integer, char, float, and name of an array in order to identify the array in a program. And row size represents the size of a row and column size represents the size of a column. That means the maximum number of elements that it can going to hold. So then let me write the example. Int is a data type here and A is the name of an array. How many subscript I am supposed to take? So 2 here and another one is 2. Will you be able to understand this? Data type is integer and name of an array is A now, and row size is 2 and column size is 2. So what it means? It is able to hold how many elements? 4. So we have 2 rows. This is row 1, row 2. This is column 1, column 2. How we are going to write the index? It must starts with a 0 always. So for row, it will be 0 and it will be 1. For when it comes to column, again it will be 0 and it will be 1. This is how we are going to represent the row and column when we are declaring a array. And here these are the subscript values or index values that represents the position of an elements. You understood? So first we have to take the data type, name of an array, row size, column size. I hope you all understood. So now we'll see the representation of this 2-dimensional array. So here you can see the representation of this 2-dimensional array. So in the previous example only I have told you regarding how to do the indexing. So here we can see the number of elements can be obtained by multiplying the number of rows and number of columns. As I told earlier, if it is 2 cross 2, how many elements can be there? 2 into 2 will be 4, right? Up to 4 element it will going to hold. It will be of 2 rows as well as 2 columns. That specifies by multiplying the row number and column number, we will be able to get the total size of an element or the number of elements. So here it will be a combination of rows as well as columns. This represents the rows and this side represents the column, right? So horizontal lines are rows and vertical lines are related to column. And how we are going to do the indexing? 0, 1, 2 up to m minus 1. So m is what? Row size and n is the column size. So here 0, 1, 2, 3 up to n minus 1. So what if I wanted to fetch the element? In which location it is? I wanted to fetch this element. It is in the location called A of 2. That is, row is in the second row and column is of third column. So that represents the position as A of 2 and 3. So 2 cross 3, that represent what? 2 represents the row number here and 3 represents the column number. What if I wanted to find the location of an element which is located here? What is the index for that, or what is its address? So it's of, let me consider the name of an array as A, and here in which row it is placing? In the row called 1, and in which column? That is 2. Okay, so for example, here I have 10. The element is 10. You just imagine I have 10 here. So it will be 10. Fine. This is how we are going to represent. And also let me consider 22, 25, 27, 29. Make it as 27, 28. Element can be anything. So now I wanted to find the location of this 25. How can I do that? Let me consider a name of an array as A itself. And what is the row? That is in the 0th row. And what is the column? It is in the first column. And what is its value? 25. This is how we are going to do the representation of two-dimensional array. I hope you all understood. Let me move to the next one, that is related to initialization of two-dimensional arrays. How we are going to give the initial value at the time of its declaration, so that we can initialize two-dimensional array either by initializing it in its declaration or by using assignment statement. So when I am declaring it, at the time only we can initialize, or else by making use of assignment operator. That is what? Equal symbol. We can make the initialization operation to this two-dimensional array. We'll see one example. Int A of 2 cross 3. So what it mean? How many elements it can hold? 2 into 3 will be 6. Up to 6 element it is able to hold. And here we have 2 rows and 3 columns. Fine. How can I write that? It consists of 2 rows will be there. Fine. Row 1, row 2, and how many columns? 3. Then how can I write the values for that? I need to write 0 and 1. So here it will be 0, 1, 2. So here it represents m minus 1. Fine. You just write down what is the row number, that is 2, and column number is 3. So if you see the representation, so here you can see that, right? What is the maximum value? N minus 1. Here it is m minus 1. So now what is m minus 1? It will be 1, and n minus 1 will be 2. So that in the column we can get the last index as 2, and in the row we can get the last index as 1. Fine. So then how many element it will be able to hold? 2 into 3, it's of 6. So you need to understand it will going to hold 6 elements. So now with the help of this assignment operator, that is equal, within the flower braces we have to specify the elements. Which are those elements? 1, 2, 3, 4, 5, 6. How can I write that? So it has to start from the first row, first element. So 1, 2, 3, and here 4, 5, 6. Then how can I write the location of an element called 1? That is A of, it's in present in which row? 0th row, 0th column. And what is the value? That is 1. This is how we are to write. Then what is the second element of first row? That is 2. How we are going to write that? You can see here A of 0, the row is 0 and column is 1 and the element is 2. So next value A of 0th row and column is 2, the element is 3. So if I finish it up this first row, again I need to come to the second row. So there this row index will going to be changed to 1 instead of 0. Fine. So here A of 1 that represent first row, and in which column it is presenting? In 0th column. What is the value? That is 4. Next A of 1 cross 1. That means first row, first column element. Index of first, index 1 and column 1. The value is 5. Here we have, and A of 1, 2. So row is 1 and column is 2 and the element is 6. This is how we are going to represent. Okay. This is one type of initialization. And also we have certain other methodology. So what we are going to do that? Here int is a data type and B is a name of an array. And then 2 cross 3, again it is able to store how many elements? 6 again, right? So here in the flower braces, I can make it as 2 rows, fine. So we have 2 rows values here and each row will able to hold 3 elements. Why? Because we have 3 columns, isn't it? Again let me write it. It is of how many rows? 2 rows and the number of column will be 3. Fine. This is what we are declaring here. But after, like when during this initialization, I have only two values for first row, that is 0th row. Let me write the indexing first. 0, 1 here, 0, 1, 2. Is it? Fine. Next, 1, 2. So I have only two elements for the first row. Then I have only one element for the second row. Then what about the remaining values? Who is going to fill that value? That too with the help of compiler. So when we have less number of elements than the size of a matrix or than the size of this array initialization, at the time by default compiler will going to allocate or assign 0 as a value for that. We'll fill the values here 1, 2. So it is of first element in the 0th row and 0th column, and 2 will be the 0th row first column. But I don't have any element for the 0th row and second column. Then it will going to be filled by what? It will be filled by 0. Next, I have only one element in the second row. It will be filled in first row 0th column 3. I don't have any other element further, so it will going to be filled by 0 as well. How I am supposed to represent it again then? Here the array name is B, so that B of 0, 0. That means 0th row, 0th column, the value is 1. Again B of 0, 1, 0th row, first column, the value is 2, right? B of 0th row and column is 2, the value is 0. Why? Because it's not initialized at the time of its declaration. And we have B of 1, 0. That means first row 0th column, the value is 3. And here B of 1, 1. So first row, first column. So here the value is 0. And B of 1, 2. First row, second column, the value is 0. This is how another type of initialization will going to takes place. So when we have a less number of elements than the size of an array, at the time by default the compiler will going to initialize that element value by 0. So that is what the kinds of declaration or initialization that can be done for this two-dimensional array. I hope you all understood. Let me move to the next concept, that is regarding multi-dimensional array. So now we got to know that one dimensional, two dimensional. If I have only one subscript, one dimensional. If I have a two subscript, two dimensional. Then what is multi-dimensional? It is of array. So when we have more than two subscript, all kind of array will comes under this multi-dimensional array. Fine. Here a multi-dimensional array is an array of n dimension. It can be any dimension. So n will always going to be greater than 2. Fine. An array of array is called multi-dimensional array. Then how we are going to do the declaration? Same story repeats. So here I need to take the data type and I need to specify a name of an array or array name will be there. Then how many number of rows and columns it will going to include. So that specifies size 1, size 2 and it goes on like this. Size n. Okay. So this is how we are going to declare the multi-dimensional array. Data type, name of an array and size 1. If I am mentioning or if I am having 3 subscript, then it is of 3 dimension. So by summarizing all together, for one dimensional array, it can be row wise or it can be column wise representation. So this is regarding one dimensional array. If it is of two dimensional array, again it will going to have both rows as well as column. This is for two-dimensional array. And if it is multi-dimensional array, then it will be more than one dimension. So this will going to be look like this. Fine. This will be multi-dimensional array. So this is regarding n-dimensional or multi-dimensional array. So this is how we are going to illustrate one-dimensional, two-dimensional as well as multi-dimensional array. We'll see the next concept. What are the operations that I can perform on array? Whether it can be one dimension, two dimension or multi-dimension as well. We'll see the basic operations on array. How to remember it, ma'am? We have so many operations here. I have a solution for you. Remember it as a TID SMS. So T represent traversing, insertion, deletion, searching, merging, and we have sorting. Fine. This is how you need to remember the basic operations on array. So now we'll see what is the first type of operations that we can perform on the array. This is regarding traversing. Traversing in the sense what? Let me take one example to make you understand what you mean by traversing. Okay, let me consider one dimensional array. Here I have 10, 20, 30, 40. So totally I have 4 elements here. Let me consider the name of an array as A itself, and here it will be 1, 0, 1, 2, 3. So what do you mean by traversing? Processing each element in the array. That means visiting each element exactly once in order to perform any of the operation. Then we are going to call that as a traversing. For example, if I wanted to reach 40, then I need to start by 10. So after that, I can jump to 20, then 30, then 40. So is visiting each element exactly once to perform some of the operation. That is what traversing. So next what we have? Insertion. As the name indicates, insertion in the sense we are adding new elements to the existing array. Inserting a new element into the array. You just imagine I have only 3 elements. Let me consider 10, 20, 30. So now I wanted to add one more element to this. Then I wanted to add 40 as a new element. Then we can do that. That is what? Insertion. Then deletion. Removing an element from the array. I don't want this 20. I just wanted to remove it. Then we can do that operation also. Then it will be 10, 30 and it will be 40. Fine. Next. Searching, finding the location of an element in the array. Already I told you regarding the location. It starts from an index 0, 0, 1, 2, 3. What is the location of an element called 30? What is the location? That is 2. What is the location of an element called 20? That is 1. So, in order searching in the sense we are finding the location or we are fetching the location or its subscript value to get to know its position or a location of an element in the collection of elements of an array. So, next what is this? Sorting. Arranging the elements of the array in some order. It can be either ascending order or descending order. Let's just imagine here I have 3 elements 18, 12, 16. Is it in order? No, right? I wanted to make it in order. Then how I am going to do that? I need to perform an operation called sorting. So it will be 12, 16 and 18. Once I perform the sorting operation, again it will be 0, 1, 2 and let me consider the name of an array as A itself. That is what? Sorting. Then what is merging here? Combining one or more array to form a single array. So I am combining one or more array to form a single array. So here I have 30, 40, 12, 16, 18. So if I am doing the merging, then how many elements it will going to be? Let me consider the first as 10, 30 and 40. So next array will be 12, 16 and 18. Fine. So when we are merging, when at the time one or more array will going to be merged together, that means its elements are merged together and it will be represented in as a single array. So then we are going to call that operation as what? Merging. So here totally we have 6 operations: TID, SMS, traversal, insertion, deletion, searching, merging, sorting. So these are the basic operations which we will be able to perform on the arrays. I hope you all understood regarding all these topics. It's all about our today's session. In my coming session, we'll see how this arrays will going to act as a ADT, that is abstract data type. And also we'll see what are the advantages and disadvantages we have with respect to the array and how we are going to represent this linear array in the computer's memory as the last topic of this chapter as well as the unit. I hope you all understood my today's session. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.